Hello students, good evening everyone. Welcome to the physics session. Try to attend the physics session at 8:30 Nana. 8:30 and we will be discussing motion under gravity concept in motion in a straight line chapter. Motion under gravity and few numericals we will work out, and also we'll work out briefly about relative velocity in one dimension, 1D. Okay? Okay guys, let us meet at Yes, students, welcome back to the physics session. Once again, right. Right, okay. That quiz still on the way? Right, okay. It takes its own time. Okay, let's go ahead. So, in the previous session, we were discussing about graphs. So, we'll see briefly again about the graphs. Then we'll discuss about motion under gravity and then relative velocity in 1D. Okay? First, graphs. As part of graphs, I don't think are you getting the voice clearly? Last rows. Once again, let me bring the speaker as.
Tomorrow 10 o'clock we have an exam. Tomorrow morning 10 o'clock, 10 to 1 exam.
Yes guys, fine. Now the voice is okay, right? Perfect. Right, graphs. Let us start with, already we have discussed about the graphs briefly about, especially position time graphs. These X, T graph we call it as. So for three different cases we have discussed how to draw position time graphs. The first case was for a body at rest. For a body at rest. position time graph is given by can be drawn by taking position x on y-axis and time t on x-axis. For a body at rest, it can be represented as at time t equal to 0, the particle or body should be at some point, at some distance from the horizon, somewhere here I can say x naught. And after 1 second it will be at same point, after 2 seconds it will be at same point, 3 seconds it will be at same point, so its position will not change, so the graph is obtained to be a straight line parallel time axis. Whereas the same position time graph for uniform motion, is expressed as position by taking on y-axis and time on x-axis. And if you observe, uniform motion means the particle should cover equal distance in equal intervals of time. If it starts at time t equal to 0 from origin, after 1 second, if it covers 1 meter, after 2 seconds, after 1 second, 1 meter, 1 meter, 1 second, after 2 seconds, 2 meters, after 3 seconds, 3 meters. Like that, if it covers equal distances, then if you extend these points, a line from these points, the point of intersection of these, if you mark and join, you will get a straight line parallel to time axis. This already I have discussed, right? And we have also discussed that the slope of position time graph gives what? Velocity. Slope is nothing but change in y coordinate. This is x, x1, x2 you can say is delta x. This is t1, t2 if you can say difference between time can be expressed as delta t. So slope of position time graph gives delta x by delta t, that is nothing but rate of change of position. This gives velocity. So here you can write as a note, what is the slope of xt graph gives velocity. Is very important point. Gives velocity. Slope of position time graph gives velocity. Slope of position time graph gives velocity. Very good. So velocity is obtained by slope or area of position time graph. Slope. Right. So whereas for uniformly accelerated motion, if you take this as x and this is t, you get a graph like this for uniformly accelerated motion. UA motion means uniformly accelerated motion. So you get a straight line like this. Is it clear? Sorry, not straight line. What do you call it? You can say it is a parabola, like rectangular parabola. Whereas next you see velocity time graph. Let us try to finish this graphs part quickly. Velocity time graph. Already as you have copied that, can I erase this? Where is the tester? I think I kept somewhere there. Right. So velocity time graph. So by taking velocity on y-axis, time on x-axis, for a body at rest, its position is not changing, means it is not having any velocity at all. So at time t equal to 0, velocity is 0. After 1 second, 2 seconds, 3 seconds, whenever you observe, velocity will be 0 only. Velocity will be 0. Not working? Some problem with this? Okay. So let us keep it aside. So velocity time graph for a body at rest is Straight line is a straight line. You can say parallel to time axis, but it is lying on time axis. It is lying on time axis. Whereas, so I am erasing this thing. Whereas, velocity time graph. Velocity time graph for a body in uniform motion. Uniform motion means what will be uniform? Velocity will be uniform, or velocity will be constant. Uniform means constant. So time t equal to 0, a body will be travelling with some initial velocity u. After time t equal to 1 second, it will be travelling with the velocity, same velocity. After 2 seconds also it is moving with same velocity. After 3 seconds also it is moving with same velocity. Velocity is constant throughout the motion. Speed or velocity, if we say velocity, uniform velocity, velocity is constant, means it should be moving in same straight line also, direction also should be fixed. So if you join all these points, you will get a straight line parallel to time axis. So velocity time graph for uniform motion is a straight line parallel to time axis. Whereas for a uniformly accelerated motion, if you observe this same graph, we take velocity on y-axis and time on x-axis. Uniformly accelerated motion means what is uniform? Acceleration is uniform, means acceleration is constant. So we can say acceleration is constant means change in speed is constant. That means you should travel with a velocity increasing or decreasing velocity. Here let us consider positive acceleration or increasing velocity condition. So velocity should increase in regular fashion, means at time t equal to 0, the body starts with 0 velocity. After 1 second, it may have some value, let us say for example 5 meters per second. After 2 seconds, 10 meters per second. And after 3 seconds, 15 meters per second. The change in velocity should be constant. The change should be constant. So if you observe this, we'll get a straight line parallel to time axis. Inclined to time axis. So from this we come across one more sentence, one more statement, that is slope of velocity time graph. Slope of velocity time graph. Slope of position time graph gives what? Velocity. Whereas the slope of velocity time graph gives acceleration. Here you can write that point. Note. Slope of VT graph. VT graph gives slope of velocity time graph gives what? Acceleration. So how can you say that? This is change in velocity, v, delta v is change in time t, delta t. So slope is nothing but change in y coordinates by change in x coordinate. That is delta v by delta t or dv by dt. That is nothing but acceleration. Is it clear? So these 2 points you have to remember. In addition to these 2 statements, slope of xt graph and slope of vt graph, one more statement you have to remember, that is in case of velocity time graph, if you observe area under velocity time graph, if you observe area means this it is in the form of rectangle. If you take this as a rectangle, or if you take this as total curve, this is initial point O, this is final point A. So this area under this, if you want to find, this will be in the form of triangle. Got it? So if it is in the form of a straight line or straight line parallel to time axis or straight line inclined to time axis, area under VT graph gives. As this is in the form of rectangle, area is length into breadth. So velocity into time. Velocity into time is displacement. Speed into time, distance. Here this is in the form of a triangle. If you consider, area of a triangle is half into base into height. Half is a number, base is time, height is again velocity. Velocity into time is displacement. Is it clear? So if you come across the word velocity time graph, area under this gives displacement. Speed time graph, area under this gives distance. So velocity, displacement, vectors are related. Speed and distance, scalars are related. This also you have to keep in mind. Okay. These are some important points. So here you can write down this. What is that? Area under what? VT. Note down this. Note down. Area under VT graph gives what? What? Displacement. Area under VT graph gives displacement. Got it? So these points remember, try to remember some briefly. Then we can draw even acceleration time graphs also. Acceleration time graph. For any way, for a body at rest, no velocity, no acceleration. So you get like a straight line lying on right axis only. Whereas for BT graph, no. So acceleration means acceleration is nothing but change in velocity. So change in velocity is 0. So for that also you get a straight line on time axis only. Whereas for uniformly accelerated motion, you will get acceleration time graph will be a straight line parallel to time axis. So can you draw that on your own? Yes, try to draw that so we can compare these graphs. This is briefly about graphs. Now let us look into next concept, motion under gravity. Motion under gravity. Right. So write down next heading, motion under gravity. Motion under gravity. Motion under gravity. So what does it mean? Gravity. What is gravity? What is gravity? Earth's gravitational force is called gravity. Earth's gravitational force is called gravity. So motion of any body under Earth's gravitational influence is called motion under gravity. If the body is moving on Earth, surface of Earth or at some height on Earth, whatever it is. Whereas if you take the body into another planet, then gravity of that planet will act. Or gravitational force of that planet will act. Okay? So here gravity is Earth's gravitational influence. Earth's gravitational force. Keep that in mind. Now, here we have to remember few points about whenever a body is under the influence of Earth's gravitational influence, we have to deal with g, small g, that is acceleration due to gravity. Acceleration due to gravity means gravitational force of Earth due to gravity. It is denoted by small g. Acceleration due to gravity. On surface of Earth, it is constant at a given point, at a given place. But it is different at different regions. At equatorial region or equator, it will be relatively lesser. At polar region, it is relatively greater or larger in value. That is the reason why rockets will be launched. You know the rocket launching center is in Sriharikota in Andhra Pradesh state, right? It is because this place is near to equator region. Their g is small, so if you are launching heavy weights, as the Earth's gravitational force is less, so it is easy to launch huge weights, heavy weights. That is why you can. It is not only here, but different places. Some rocket launching centers are established, but this is one of the major point and influence it is involving there. You can understand. So you have to recollect back the concept about g from gravitational or gravitation chapter. Gravitation, acceleration due to gravity changes with height, depth, latitude, etc. All these points you have to remember. Next, here, mainly as discussing about motion under gravity, we will discuss few special cases. First case is freely falling motion. Freely falling motion. Freely falling motion. What is freely falling motion? What is freely falling motion? Whenever you drop a body, whenever you drop a body, this drop means you are not projecting it. Just you are dropping means the body is starting from rest or starting with a zero initial velocity. So that is called a dropping. Okay, if you drop a body, if your body of mass m is at some height, initially it is at some height h from the ground. from the ground. Now if you drop this, it's some initial velocity 0, it's some initial velocity 0, then because Earth is pulling because of its gravitational force, it tries to fall on this. Because of this Earth's gravitational force, as force equal to mass times acceleration, force is acting means it is moving with some acceleration. But acceleration will be constant here, that is equal to g at a given point, right? So as it is considered as because g is constant here, you can say acceleration is constant. So motion under gravity is considered as one of the case of uniformly accelerated motion. But here acceleration A will be equal to g plus or minus the sign you can consider accordingly. But usually as it will be acting downward towards the center of Earth, you have to follow some sign convention. So the different books will give you different sign conventions, but you guys try to follow the sign convention given in NCERT. That is what is, I am giving you briefly that. If you consider this is Cartesian coordinate system, like the horizontal line is x-axis, vertical line is y-axis, and let us consider this is origin. So from the origin, the line towards right will be taken as positive, towards left will be taken as negative, upward will be taken as positive, downward will be taken as negative. Got it? That means acceleration, if acceleration is upwards, then it will be taken as positive. If it is downwards, it will be taken as negative. Rightwards, positive, leftwards, negative. That is what is the meaning of sign convention. Now, here, when a body is under gravity, always gravitational force is acting on it. Right? So, the acceleration will be downward means downward acceleration in any parameter, not only acceleration, the displacement, velocity, acceleration, any vector quantity which is acting downward will be taken as negative. So in this case, acceleration A will be taken as minus g. Is it clear, everyone? Acceleration of the body is nothing but acceleration due to gravity, because the force acting on this is gravitational force. Now, and we have to consider some conditions. Conditions like, on this only Earth's gravitational influence only should act. Gravity only should act. No other external forces will act on the bodies. No other external forces should be considered. Like air is blowing. So if you drop a body from the first floor onto the ground, if air is blowing, then it may take the body may not fall directly downwards. The body will not fall directly down. If air is blowing, it may if you drop, say for example, on some a piece of paper, if you drop, if the air is blowing in this direction, it may travel that direction, then some other direction, then some other direction, then fall. It won't fall, it won't follow the straight line path. That's why if you ignore all other external influences like air, wind, right, etc., that is especially in vacuum, it follows straight line path, and that only G will act. That condition only have to take into consideration. Now, under that effect, we'll try to find few parameters like when you drop a body under the influence of Earth's gravitational gravity, how much time it takes, first thing. And second thing, what is, if it starts from zero velocity, what is the velocity obtained by this body just before touching the ground or hitting the ground? These two are very important parts. If h is given, in terms of h and this g, how to find the time and velocity? If any of those parameters are given, you can find h also. Those things we'll see later. First thing, let us see to find final velocity. Let us say this is point A, this is point B. So final velocity at B before touching the ground. To find velocity before touching the ground. So I am not going to give the entire the derivation step by step, but briefly I will give you the steps which are involving. So to find the velocity at B, actually here initial velocity is there, final velocity you have to find by using acceleration. Which of the equations of motion you have to use which is involving u, v and a, and of course distance traveled will be nothing but the height. So you have to remember that all the equations of motion is you have to cross check once. First one is v is equal to u plus at. Second one is s is equal to ut plus half at square. Third one is v square equal to u square plus 2as. Fourth one is distance traveled in second. So we don't want that. We want only in terms of velocities and acceleration. So if you observe the third one, yes, it is involving initial velocity, final velocity, acceleration, distance covered or displacement covered. So by using this third equation, we can say that v square at b is equal to, at a u velocity is 0, so 0 square plus 2 into acceleration is downward, so minus g, displacement is also downward, is equal to h, minus h. So minus into minus becomes plus 2gh. So Vb is equal to square root of 2gh. Is it clear, everyone? Right? In case of the freely falling body, the velocity of the body before touching the ground after traveling a distance h is square root of 2gh. Whereas how much time it may take to find this? By knowing the distance traveled and acceleration and initial velocity, how to find time? Distance, initial velocity, acceleration. By knowing it, how to find time? Which equation you can use? Second equation. So to find time, you can also call it as time of flight. In this case, the time taken by time is spent by this body in air before touching the ground is called time of flight. So this can also be called as time of descent. Time taken to travel from maximum height point to ground is called time of descent. So all are same in this case. Okay. So to find time t taken by the body to reach the ground, we have to use this relation. That is s is equal to ut plus half at square, where s is displacement travel downward minus h is equal to u is 0 plus half into a is minus g into t square. So minus of gt square is equal to minus h, minus cancel. So t is equal to 2h by g under root. This is the time taken by the body to reach the ground. Is it clear? Yes. These are two important points you have to remember related to freely falling motion. This is one of the examples of motion under gravity. Another example, very important example, is the body projected vertically upwards. The body projected vertically upwards. 9.5 or 9.10? 9.10? Oh, okay. So just let me wind up this quickly. I think other sir may take. Other physics sir has taken from 7 to 8? No? Okay. So sir also want to take maybe for 40 minutes. Let me finish quickly this. Whereas the next case is vertically projected body case. That is also another example of motion under gravity. Motion under gravity. Yes. Let us see that. Let's write down subheading. The body projected vertically upwards. This is again another example of motion under gravity. The body projected vertically upwards. Vertically upwards. Upwards. From where? From the ground or from top of a tower also. From ground or from top of a tower. So let us consider the case of from top of a tower. So that from the ground case also is similar to that. But I will explain orally. I just have to remember the points. If a body of mass m is projected vertically upwards with some velocity u, because the gravity is pulling down, the force F is equal to mg acting downwards. So that acceleration of the body, the acceleration with which it is moving, will not be considered as some other acceleration. It is due to gravity. Acceleration, force acting on this is due to gravity. So acceleration of the body is also due to gravity only. So acceleration will be taken as a equal to g, plus or minus. As gravitational force is acting down, so we have to take it as a equal to minus g, even though body is moving up. This doubt may come to many of you guys. Body is moving up closer, so acceleration has to be positive, right? No. Why? Because force is acting down, so acceleration due to gravity is acting on it, that is acting downwards. So we have to take acceleration is equal to minus g. Okay? Now as because force is acting down, speed will decrease gradually, and after reaching some height, maximum height h, it stops. So this is initial velocity here, let us say this point A, at this point B, the final velocity will be 0. Stops. Then again it travels back and reaches the ground. Is it clear? Once you project your body, and let me draw this little bigger one. If you project a body of mass m with initial velocity u from ground, it travels to some height h, then here it stops. Means final velocity will become 0. Final velocity becomes 0, then again it retraces its path. Means now for the next path will be taken as freely falling case only. Here initial velocity for this path is 0. Before touching the ground, it appears maximum velocity. We have to remember that velocity is equal to exactly this velocity. Okay, that is one thing you have to remember. Next point is, here, especially main important point is, what is the maximum height raised by it when you project with this velocity u? At maximum height, final velocity should be 0. So, the acceleration a should be equal to minus g. Here also, to find this maximum height reached by the body, h max, you can call it as h max. You have to use one of the equation which relates initial velocity, final velocity, acceleration and displacement travel, distance travel. So that is nothing but v square equal to u square plus 2as. From that you can say as, you can write at the heading, to find maximum height. To find maximum height. To find maximum height, h max. To find h max. So what you have to take? Which equation? V square minus u square equal to as. V square minus u square equal to 2as, or v square equal to u square plus 2as. Where v is 0. U square is, u is upwards, so positive. So minus of positive velocity square is u square is equal to 2 into a is minus g. H is in upward direction. Displacement is upward direction. Plus, so plus h. So you can write minus u square equal to minus 2gh, minus minus gets cancelled, this h is nothing but h max. So from this you can say h max is equal to u square by 2g. This is the maximum height traveled by the body. So it depends on the velocity of projection, as g is constant. If you project with larger velocity, it goes to larger heights. That's it. It does not depend on the mass. One more point I thought to give you. The maximum velocity obtained by the body when it reaches the ground. Sorry. So in case of freely falling case, the maximum velocity obtained by the body before touching the ground is v is equal to square root of 2gh. Remember, here it does not depend on the mass. That means if you drop one chalk piece on 10 kg body from same height, where in vacuum there is no other external forces to be present, there both will take same. Both will obtain same velocity and reaching the ground, because it, of course it depends on the height from where you are dropping and g, not on the mass. Even the time taken by the body is t equal to what? In case of freely falling body, square root of 2h by g. It also depends on height only, it does not depend on mass. So both will take same time to reach the ground. Even if you take a feather of a bird and a 10 kg object, both will take same time to reach the ground. So this, based on this kind of conceptual points also may get some questions. You have to understand the concepts more clearly. So let us come back to this. Project to the body case. So maximum height is given by h square, u square by 2g. It depends on the initial velocity of projection. It does not depend on mass. Then what is the time taken by the body to reach that maximum height? We call it as time of ascent. Then what is the time taken by this to reach the ground? We call it as time of descent. Then what is the time taken by the body once you project to go to maximum height and come back to the ground? That time is called as time of flight. Time of flight. So here directly I am giving you time of flight, capital T is equal to time of ascent plus time of descent. Time of ascent plus time of descent. So in this case, what is time of ascent and time of descent? In the absence of external forces, both are equal. So you can also say it is equal to 2 times time of ascent or 2 times time of descent. So what is this time of ascent or time of descent? To understand this, you have to use the equation of, what is the second equation, is equal to ut plus half at square. By using that you will get this one. 2 into this. Is it clear? 2 into this. So t, time of flight, is equal to 2 into square root of 2h by g. Got it? 2h by g. Right? So these are some important points related to what you call projected body case, and remember for relief falling body case. Here some other special cases will come. So if you remember this, you can go through those and you can answer those as well. So I'm just winding this concept of motion under gravity with this. Now let us see briefly about relative velocity concept. Relative velocity in 1D, one dimension. Let's write down, let's subheading. I'll copy these points. Yes, everyone? Right? Then write down, next subheading, relative velocity in 1D. Relative velocity in 1D. In one dimension. Relative velocity in one dimension. So first of all, what is relative velocity? Can I erase this? Right, listen. Relative velocity. What is relative velocity? Velocity of one body with respect to another is called relative velocity. General. So write down. What is relative velocity? Velocity of one body with respect to another. Velocity of one body with respect to another is called relative velocity. Right? Relative velocity. So, especially in case of 1D motion, one dimensional motion means a straight line motion, while calculating relative velocity, you have to use one simple relation. I will give you one general formula. Relative velocity of a body, relative velocity of a body, one with respect to 2 means you have two bodies, first body and second body, with respect to 2 is represented as V12, velocity of one with respect to 2. We can also write it as velocity of body A with respect to B. So different books will give you differently. You have to follow the subscripts VAB or VPQ or V12. The subscripts you have to follow accordingly. Okay. Velocity of one with respect to 2 is equal to general formula. Velocity of first body plus reverse velocity of second body plus reverse velocity of second body second body. Got it? Only in one dimensional case. In two dimensional case, some angle also will come. That is a different thing. We'll see later. Again, motion in a plane chapter, we'll discuss that. Relative velocity again will come across there. As part of the relative velocity, we'll discuss about riverboat problems, rain umbrella problems, etc., etc. Okay. Right. Relative velocity of one with respect to 2 is equal to velocity of first body plus reverse velocity of second body. Right. You can put this in a box. Let us see here. As a special case, some examples. If the body A is moving with velocity VA towards the right, there is a body B which is moving with the constant velocity VB towards the right, and they are different. Both are moving parallel to another side by side, or VA is here, B is here. Both are moving in same direction, provided same direction. Then velocity of A with respect to B is equal to what? A is moving in positive direction, so velocity of the first body is positive plus VA plus reverse velocity of B. B is moving in positive direction, reverse velocity of B will be in this direction, minus VB. That is the meaning of reverse velocity of second one means. So, plus of reverse velocity of VB is minus VB, so you can write it as VA minus VB. VA minus VB is velocity of A with respect to B when both bodies are traveling in same direction. Got it? Everyone? Same direction. same direction. Whereas second example, next example right now. Find relative velocity of the two bodies shown in figure. Find relative velocity of two bodies shown in figure. Here, A is traveling with velocity VA to the right, yes, and B is traveling with velocity VB to the left in opposite directions. They are approaching each other. Opposite directions means they are approaching each other in this case. In this case, or the other case also you can say they are traveling in opposite directions means they may be moving away from one another also. Away from. That means A is moving in that direction, B is moving in this direction. So that is A is moving in this direction, B is moving in this direction. In both cases, with VA, with VB. For both cases, it is applicable. In this case, velocity of A with respect to B is A, B means first one will be A, second one will be B. So velocity of A is moving in this direction, positive x direction. So VA, B is moving in this direction, negative x direction. Towards left means negative x direction. Reverse velocity of this will be in this direction. So that is, actually this is negative x direction. So reverse of this will be plus VB. Actually this is minus VB actually speaking. So reverse of this is in positive x direction. So you can take it as this. So what is this? VA plus VB. VA plus VB. Is it clear everyone? So in this case, VA is in here. The velocity of A with respect to B are asked. This is first and this is second for us. So VA, reverse velocity of that will be in positive direction. So plus VB. So same thing is applicable. Got it? This is how we have to calculate relative velocity of one body with respect to another. Okay? This is briefly about relative velocity case. Now I am winding the session. Okay? We can go through this synopsis points and also the numericals which you have examples. In place of this, you have numerical values. So it is moving with 5 meters per second, it is moving with 10 meters per second. What is this? Numerical values we get, that's it. Okay? So try to go through these examples, whatever you have discussed, and practice yourself and try to go through few previous years questions. Possible. Okay? Right. Okay then. We'll meet in the next session then. I'm winding.